welcome to the world of water once again. So, in our previous video, we discovered and learned about what is hard water and why we are not able to form lather with soap. After that, we came to the platform that whenever we express the hardness, we have to do it in terms of equivalence of calcium carbonate, and there were basically two reasons for it. One was that its molecular weight is 100, so that makes it easier for the calculations, the numerical value. And the second reason was that it is one of the most insoluble salt in water, so it's easy to precipitate out of water and doesn't participate in the hardness, right? And to convert it the hardness into the equivalence of calcium carbonate, we use a mathematical expression, that is strength of the salt multiplied by the multiplication factor. Okay, so now today we'll be doing a little bit of practice upon some of the numericals related to the hardness calculation. We start with the question, and the question says calculate the temporary hardness of the sample of water containing magnesium bicarbonate. So we have magnesium bicarbonate in our water sample, and what is the strength given? The concentration, it is 73 milligrams per liter. And what else does it contain? It contains calcium bicarbonate, which is actually 162 milligrams per liter, and magnesium chloride, which is actually 95 milligrams per liter. So before starting with some numericals, we have to keep in mind very basic thing. And what is that basic and important thing? It is that first step is we have to convert these concentrations of the respective salts in terms of equivalence of calcium carbonate. So the very first thing in any of the numerical of hardness of water, we do the conversion thing. Okay, so let's start with that. I'll do the conversion here also, so that means I'll solve the numerical here only. We have magnesium bicarbonate, one of the salt, concentration is 73 milligrams per liter. So I convert this into equivalence of calcium carbonate first. How do I do it? Which is equal, actually that is equal to strength of the salt, which is 73, okay, multiplied by multiplication factor. And what is multiplication factor? Actually it is equal to the equivalent weight of the calcium carbonate divided by the equivalent weight of the hardness causing salt. So I multiply 73 with what? The equivalent weight of calcium carbonate. And what is the equivalent weight? Its molecular weight is 100 and its oxidation state is 2. Calcium oxidation state in calcium carbonate is 2 plus 2. So I divide 100 by 2, I get the equivalent weight of calcium carbonate. Now I divide this factor, this particular value, by the equivalent weight of the salt. Which salt? The hardness causing salt. And what is that over here? I am dealing with right now magnesium bicarbonate. So I divide this figure with the equivalent weight of magnesium bicarbonate. For what? And for that, what I do, I take the molecular weight or the molar mass of the magnesium bicarbonate, which is equal to 146, divide by 2, because 2 is the oxidation state of magnesium in magnesium bicarbonate. Okay, so after solving, now this part within the brackets, it is actually the multiplication factor that was referred here. So what do I get after this? I get 50 milligrams per liter equivalence of calcium carbonate. Okay, so now I have converted the figure for magnesium bicarbonate into the equivalence of calcium carbonate form. Similarly, I will go for calcium bicarbonate. So this will be equal to the concentration or the strength of the solution, the salt given in solution, which is 162. Multiply it with what? Equivalent weight of calcium carbonate, which is 100 upon 2. Now divide this equivalent of calcium carbonate by the equivalent weight of calcium bicarbonate, which is the salt here causing the hardness in this case. So how do I do that? I take the molar mass of calcium bicarbonate and I divide by the oxidation state, which is 2. And what do I get after solving this all? I get 100 milligrams per liter equivalence of calcium carbonate. Okay, fine. Last of all, I then come to magnesium chloride. This is equal to 95, which is the concentration given over here, multiplied by what? The multiplication factor. And what is that? 100 upon 2 divided by equivalent weight of magnesium chloride, which is actually 95, which is the molar mass of magnesium chloride divided by the 2. So what do I get over here? I will get, after solving this, 100 milligrams per liter equivalence of calcium carbonate. Now all these salts whose concentration was given in the question, I have converted into the equivalence of calcium carbonate form. Now I will calculate the hardness, whether it is temporary or permanent or total or whatever it is. Okay, so here it is asking for temporary hardness only. So temporary hardness, I know it is due to the bicarbonate of calcium and magnesium. And what do I get from the bicarbonates of calcium and magnesium? These two are the salts. For magnesium bicarbonate, I got 50, so I write 50 over here. For calcium bicarbonate, I got 100, so I write 100 over here. So total temporary hardness is 150 milligrams per liter, or we can also write as 150 ppm. Why? Because 1 milligram per liter actually is equal to 1 ppm. So this is my final answer for the question.